Hello, this is Paul Song demoing Lab 2 for ECE 4862 for part 1 of the lab, which was the RTC and timer. Nothing hardware was required, but for the second part, which was the ADC timer, I have pin 32 as a input from the ADC where it takes in the voltage reading from the 3-volt port of the ESP32 into the potentiometer here, and then it takes out the output from the potentiometer and back into pin 32. And yes, the potentiometer is connected to the ground, and hopefully once we move this we will get the reading for part 2. But right now I'm gonna be demoing the RTC and timer. I'm gonna save here real quick, and then I will run that. Okay, year, let's say 2023. Enter. Month is October 10. Day, today is the 6th. Weekday, today is a Friday, so that will be 4. And then hour, right now it is 8:09, so I think that takes a 24-hour time, so that'll be 20. And then minute, 9 second, I'll say 0 millisecond is 0. Then we'll take 30 seconds to output the current date and time. We'll wait here for a few seconds here, and while that does that, I can explain the next part of the hardware, which is the LED in the PWM. So the LED is connected to we have a resistor here connected to pin 27, which is the output of the PWM, and then we have the LED connected with the same row as the resistor into the ground, and then hopefully that'll help. And look here, now we get the current date and time, 2023 October 6th. It is weekday is 8 o'clock, 8:09, 30 seconds. Then we get the milliseconds, and then we see that a minute has passed, and then the next output. Okay, I'll stop that now. Reset, and then we will see the pulse width modulation, or the ADC timer. Not the ADC timer. Yes, the ADC timer. We'll see that. And then we can show the LED and PWM as well, but not the last part. We'll save. Run. See, we can see right now the output of the ADC, and then if we turn, we can see that it went all the way to the max, and if I turn the opposite way, currently it is going all the way down to 0, and this is about halfway, I believe. There we go, it's halfway, and I'm still turning, and it's going. And we can also see that LED is set to pin 27, pin out, and the PWM is set to a frequency of 10 and duty cycle of 512. And we can see the current light bulb flashing right now. And then if we stop that right now, we hit reset, and then we open the switch press, uncomment that, and we save, and we run this. We can show the different functions of the potentiometers after pressing the button. So I have button set out at pin 38 and an input, and then the timer we're using as third timer, timer 2. It calls a interrupt handler debounce. The debounce function counts the number of buttons pressed up 1, and then it calls a timer function every 50 milliseconds, and it is periodic. And then the callback is this switch function where I take the count, and depending on what the count is, I change the function of the potentiometer. So now we can run it. You can see this running now. We press this button, and this second function is the frequency. So it is at halfway, and then it's getting brighter and brighter, and this is getting slow. This is the lowest frequency. And then we can see that turning the potentiometer, the frequency of the light bulb gets faster and faster, and then all the way it seems like it is constantly on. And then go middle, it's flashing a little bit faster, slower I mean, and then all the way at the end it is flashing as slow as possible. And then function 3 is the duty cycle, and this is the minimum duty cycle, so we can't see. And then as I turn it, it gets brighter and brighter. The frequency stays the same, brighter and brighter, until it is so bright and still flashing. And then when I press the button again, it goes back to its normal function, where turning the potentiometer does not do anything. The frequency and the duty cycle stays the same. And then I press it again, and it changes the frequency, and the light bulb, the frequency of the light switches as I change the potentiometer.